Now, very quickly, this is what the syllabus includes. I am not going to go through this. Later on, you will see what it is all about. Just a quick introduction. In stats, when we say dependence, all right, anything is, if you say two variables are dependent, it's just very loosely they are dependent. That's all. But correlation is exactly what, maybe one increase, the other decrease. Or maybe they are related by an equation called y equals x squared. That is correlation. That is correlation. Dependence is a very broad category. It's very loose. But correlation really means that they are really correlated by an equation, linearly correlated by quadratic, etc., etc. Okay? Dependence maybe just say just by rank. All right? Familiar examples, just now I've gone through quite a few, like your H2 math score, H2 econ score, etc. That's possible. Correlation are really useful so that we can make use of them. You know what I'm saying? If you tell me, for example, the dark chocolate thing, if really is positively correlated, many people will rush to the chocolate stores and buy a lot of dark chocolate and eat. Possible, right? After the findings. Or you tell me H2 math score and H2 econ score positively correlated. That means they are related. You study hard for one subject, then you can actually do well in the other as well. Correct? Yes? That informs you and helps you make some decision. Okay, before I continue, I must first say that this set of notes, there are a lot of things that are printed, which doesn't give you any excuse to start talking. All right? This is really the last set of notes already for stats. Yeah? So just pay attention, just stay focused. We start on time, we end on time. Okay? What is bivariate data? Bivariate data essentially when we talk about, remember when we did normal distribution, hypothesis testing even, we are talking about one data. That means whether it's height or pizza delivery. We are talking about one set of data. Only one type of data. Now in correlation, we are talking about two sets of data. Correct? The relationship between two sets of data. So we need to have bivariate data where you have this, one pair and one pair. x1, y1 and x2, y2. That is called a set of bivariate data. Okay, we will be interested in looking at one pair rather than just height or weight individually. You know what I'm saying? All right? Okay, what is a scatter diagram? Remember the slide that you saw just now? Remember this one? Wait, sorry, not this one. This one. This one. This is what we call a scatter diagram. Correct? This is what we call a scatter diagram, where each point constitutes one data point. Okay, this is what we call a scatter diagram. Now, it is super useful to give us a very good visual impression or visual representation of the actual situation. Correct? Just now you look at the data points, one look you can tell me, hey, eating dark chocolate is good. My life gets, I live longer. Is that alright? Okay? So, let's take a look at a quick example. Stats quiz and language quiz. Okay? X is the stats quiz. Y is the language quiz. Okay? Then this is one set of students. That means he got 1 mark and he got 3 marks. 2 marks, 5 marks. 3 marks, 8 marks. 4 marks, 9 marks. That kind of thing, alright? Give a sketch of the scatter diagram of the data as shown on your calculator and comment on the relationship. Now, look, I am not about to go through the keystrokes to sketch a scatter diagram. I'm not about to, you have to look at your Just For You guide. Just For You guide, correct? Just For You guide. So, of course, the other way to do it is you can tell me, I plot x-axis, y-axis, I only have 5 or rather 5 points. Yeah, dot lah. Why do I need to use GC? True, no need to use GC for these 5 points. I agree with you. But in your exams, you may have 10 points, 15 points, or in real life, you will have 200 points. Are you going to do it by hand? I'm talking about real life, seriously. Or may not even 200, 500. You want to have a real accurate, you want to have a representation, visual representation. So in real life, you use computer, you don't use GC already, right? Then you use technology. So here we also use technology, but our technology a bit low tech, use GC. So not about to go through that. But once you get the scatter plot, you will be able to plot all these points. Is that all right? Okay? The GC will give you something like that. Then it is your job to transfer what is on your GC with proper scale and labeling of the axis, the dots, to your script. Alright? Just dot. Nobody is going to fault you if you say, oh, actually it's 1 and then 3, and then you go off a bit and then you put 3.2 here. Nobody is going to fault you. As long as the general trend is there, it's fine. Okay? Ken? Look, the points on the scatter diagram seem to lie on a straight line. Seem to. Look, upward trend. Seem to lie on a straight line, this straight line. So there could be a linear relationship without actually doing any math. It's just plotting. Not bad, what? It seemed to be a linear relationship. Right? There seemed to be a linear relationship. Now, when the question asks for a scatter diagram or scatter plot, just make sure the following 3 points or 4 points. It is of a reasonable size. Don't draw some of your I mark your CT2 script, some of them. Some of your graph, 2 cm by 2 cm. How am I going to see? No such thing, reasonable size. Label your axis, that means if it is X and Y. Or maybe stat score and language score, something like that. Point number 3, a suitable scale to mark out, of course. Okay? Points are plotted in reference, that means if it is a 1, 3, you don't plot 3, 1. Okay? Obvious. Okay? Okay, let's do a bit of definition. Now, I have actually used the word correlation right from the start because I assume that you know what it means. Right? English, right? You don't need H2 math to know what is the meaning of correlation, right? Alright? If it's positive linear correlation, this is somewhat the scatter plot. Correct? Yes? If Y decrease as X increase, something like that, that's what we call an inverse or negative correlation. Correct? Negative correlation, downward trend like that. Okay? Maybe this is height, this is intelligence. Something like that. Something like that. Okay? But if you realize that, my scatter plot look like this all over the shop, there's no correlation, right? That means they're not really that related. Correct? Yeah? So they're not correlated, uncorrelated, no correlation. Now, we need, the scatter plot gives us a very visual look. One look, you say, roughly it is correlated. But we need to be a bit more scientific. There should be some number that give us a sense that without, this number means good correlation. This number means not so good correlation. That number we are going to learn today. It's called the correlation coefficient. Alright? correlation coefficient, this one. Okay? And in particular, there is one particular coefficient that we use. It's called the Pearson's product moment correlation coefficient. Wow, what a mouthful. But never mind. Anyway, this is the only correlation coefficient you know and you will learn. So just one, okay? Given in the formula list. Okay, can I highlight this? It is a numerical value. It's a numerical value that lies between -1 and 1. Which is excellent because 1 tells us something, -1 tells us something, 0 tells us something. And I think some of you are able to guess what actually it means. Okay? But before that, can we take a look at this formula? Don't have to worry too much. It is given in the formula list. All you need to do is to know how to enter into a calculator. Quite brainless. If they give you 5 marks to calculate R, I tell you, you must, anyway, something must be very wrong, impossible. But you must know what is this, right? This is read as one term. Can I have attention? If you look at this, this is read as one term. That means for one value of x, what do you do? For one value of x, you will take the x1 minus the x bar times the y1 minus the y bar. That is considered one value. Then after that, you take x2 minus x bar, then y2 minus y bar, that's another value. Then you sum them all up. Because your bivariate data, right? x1, x2, right? Remember? So x1 minus x bar can calculate, right? Y bar also can calculate, right? Then you sum them all up. Okay, good news. Unlikely that they will ask you to calculate like that. Until you will go crazy. And then no point like H2A level, go and do this kind of thing. So time wasting, right? Never. But you must know what it is. You must know what it is. In case they ask you to calculate. But usually what we will use is this one here. Usually we will use this one. This one is easier. They usually will give you this summary of data where summation xy. Summation xy means your x and y data, bivariate data, right? X times y, that's one. x2, y2, that's another one. x3, y3, another one. Then sum them all. Usually they will give you all this summary. Summation x, summation y, etc., etc. You know what I'm saying? Don't bother memorizing, it's given in the formula list. Okay? Okay? R is the sample correlation coefficient, right? Because given the data points, it's the sample data. Hence, it estimates the actual correlation coefficient. Okay, now this is very easy. Positive means there is an upward trend, means positive linear correlation. Or can I emphasize here, what we are talking about is linear correlation. We are not interested, I would say not interested. We are only talking about linear correlation for now. Okay, that means lie on a straight line or not. Correct? Yeah? If it's negative, means the slope is negative lah. Alright? Yes? Okay? What if it's 0? 0 just means that they have no linear correlation. But, can I highlight this point? But, x and y may have a non-linear relationship because R only measures linear correlation. But R equals 0 just means that they are not linearly correlated. But they could be non-linearly related. Okay? Then we take a look at R equals to 1 and -1. Easy lah, huh? Do I need to say more? 1 means lie on a straight line, perfect straight line. -1 means lie on a perfect straight line, but it's downward sloping. Okay? Let's take a look at some examples. Look at some of the scatter plots. And this one means perfect straight line, right? So R -1. Alright? Negative 0.8, not bad, but doesn't lie on a perfect, not all points lie on a straight line. This one, all over the shop, r equals 0. And on, you all go and read lah. Huh? No big deal. Example 2. Calculate the product moment correlation coefficient for the data in example 1. Okay, this one I want to go through with you. How do you use your GC? How do you use your GC to calculate the product moment correlation coefficient? Now you go to your GC now. Okay, what are you about to do? You are to enter your X and Y into your L1 and L2. Okay? If you have just for you guide, you can refer to it and move on according to your own pace. But if you don't have, then just follow me, alright? Example 1 says you need to so your X data 1, 2, 3, 4, 5. You want these sets of data to be stored into L1. So you store it, here, into L1. Enter. Alternatively, you can edit list. Is another way. Alternatively, you can edit list and enter them in. No problem. Alright? Then you do the same for your Y. Okay? 3, 5, 8, 9, 10. 8. Okay, now what do? You go to Stat, calculate, for, and then your X list. Now note your X list is okay. For now you don't bother. You just put L1, L1, one for L1, one for L2. Okay. For now you don't bother. Okay. Okay. Never mind. I need to do something. Yours should have R. Does yours have R? Okay. Mine don't have because I need to do something. Okay. Mine will have R now, okay? Okay, that's your R, okay? You should see your 0.976 out. That's how you calculate R, given a set of data points. So easy, right? 1 mark only, don't be so happy. Okay? Okay? Okay, so solution 0.976. Okay, 0.976. Now, what do we say a bit more? Comment on its value. Since R is approximately equals to 1, it could be a strong linear correlation between X and Y. Okay, strong positive linear correlation. All right? Now what about B? B really just substitute values. You know what I'm saying? You are given all these summation X, summation Y, summation X squared, Y squared, summation X, Y, and N. Just throw in all the things. I'm not about to make you do it. waste of time, right? Insulting your intelligence, but just substituting into the formula. Okay? And you get answer. 0.823. Is that alright? Okay? Ken? Alright, let's move on. Okay, this is important. I cannot stress enough. I really cannot stress enough. This is really important. You have to consider. You should not just be happy if R is 0.926 or 962. You have to consider the value of R together with a scatter diagram. Why do I say that? Let's see the following example. Let's see the following example. Let's look at A, the set of data A. Negative 2, 4, negative 1, 1, 0, 0, 1, 1. Then we are trying to find out the R. Can we find R? We can, right? No big deal. Okay? Given, right? This one, R equals to 0 in your notes, right? Okay. So I'm not going to make you go through the exercise and calculate R again from the calculator. But I tell you, if you key in, you will get R. What does it tell us? What does it tell us? It tells us no linear correlation, which is correct. But we are not about to stop there. We are about to investigate a bit more. If we do a scatter plot now, scatter plot, that means plot all the points, you realize you get this. Minus 2, you get 4. Minus 1, you get 1. 0, you get 0. 1, you get 1. 2, you get 4. You realize that actually they seem to lie on the line y equals to x squared. Am I right? So while we are right to say that they are not linearly correlated, we are right, we're not wrong, but there seem to be some kind of correlation, which is they are related by a quadratic equation. Seem to be. Okay, there is a relationship, just not linear. So don't be too quick to jump R equals 0, I don't care. You know what I'm saying? Okay? So just a quick note. R equals to 0 could mean that there's really no correlation. That means if R equals to 0 and the scatter plot are like all over the shop, are those kind really no correlation? But if you see this type of R equals to 0 and they seem to lie like that, there is a relationship, but just not linear. But just not linear. So you have to consider both R and the scatter plot. Okay, 2. Okay, let's take a look at part B. You have this set of data, right? Then I'm not going to ask you to go through the exercise to find R. Okay, you have done it once. Okay, if you go through the exercise on your calculator, you will get 0.862, which is a very strong indication of a positive correlation. Then we are not about to stop there. We draw a scatter plot. So if you really do a scatter plot, you look at the data, this is what you see. This is what you see. Oh, this is what you see. Now, let's be a bit more critical when we see this. Let's not just accept R equals to 862. Let's be a bit more critical. If there is some experimental error, you read the whatever thing wrongly, and you got this point by mistake. Yours, do science, right? Some chemistry, right? Chemistry, right? You're going to do measure. Of course, you go to lab, sometimes you make some silly errors. This one is an error. Had this one been an error, falsely recorded, actually, is there a correlation? There is no correlation. You know what I'm trying to say? Huh? Yes or no? You get it or don't get it? Yes or no? Yes, huh? If you ignore this, that means this really there was a mistake in recording your data. You don't care about this one. Take a look at this 9 data. There is actually no correlation, you know. I don't need to calculate R, I will know. R is 0. Almost 0 at least. So, what I'm trying to say is don't just rely on R. You look at your scatter plot and this R has been distorted artificially by the 0.98. Hence, moral of the story. Moral of the story, always check against your scatter diagram. Get it or not, Paul? Okay, Ken? Okay, example 4. Okay, for the sample in figure 1, here, state an approximate value for the linear product moment correlation coefficient R. Roughly, any guesses? What? 0.5? Negative? 0.9? Negative? 0.8? 0.7? Whatever. Okay, good. Okay? Good guesses. Okay, 0.8. Actually, if you calculate 0.8, if you give anything between 0.9 and 0.7, you actually get, it's actually correct. Okay? Okay? What? You want to put that one? How you know? Somebody say we got to put 0.852863, whatever. No lah, how you know, right? Don't put this kind of thing. Okay, let's see. Now, part 2 is interesting. You look, this one seems to lie on a perfect straight line. And it is, you really calculate the R, you indeed get 1. Explain why this does not imply a linear relationship hold for the entire population. Sorry? 0, 0. Okay. But even for here, may not be true. It may not come from a linear. Yes, Wei Chen? Small sample. Oh. Small sample. Very good. Very good. Because you only took how many points? 1, 2, 3. Let's say, for example, I take a relationship between H2 math score and H2 econ score. I take the 5 of you. For example. Then I realize linear correlated. Well, really perfect. R equals to 1. The higher your math score, the higher the econ score. Does it mean that for the rest of you it's true? No. No. Because I only took the 5 of them. You know what I'm saying? So if you have not taken enough data points, you cannot conclude so fast. So, it may be linear by chance. That's why the 5 of them may be linear by chance. You know what I'm saying? Okay? Yeah? Okay, next thing I want to stress is this. Ready? Finish copy? Causation, correlation not equal to causation. Okay, the moral of the story is before I just say it first. What do I mean? That means dark chocolate. if really it is indeed true, correlated, eating a lot of dark chocolate will increase your lifespan. It is correlated. But does it mean that eating dark chocolate will cause you to live longer? May not. I will explain. Positive correlated, does it mean causation? What we see on the surface is this. Correct? That's what we see on the surface. What could mean is, because you are richer, they eat a bit more dark chocolate. I mean, seriously, have you seen really, if you're poor, you won't eat dark chocolate every day, right? Correct or not? Okay? So you have higher income, hence you eat a bit more dark chocolate. Then, if you have a bit more money, you have better medical care. Better medical care, of course, you live longer, what? Correct or not? I mean, I'm just saying it very generally. This is possible. So you don't just look at on the surface and say, this correlated, hence this caused this. Be a bit more critical, that's what I mean. Is that alright? Yes? So the same goes for other kind of findings that you read on the papers. Be a bit more critical. Alright? Okay. Next part, we will go on to what we call regression, linear regression. Okay, before I do this, let me